Hello students, now in second lecture of chapter 5 we will discuss these points. First point, magnetic dipole moment of a revolving electron. We have seen in the lecture 1 that if the charge is moving it behave like a dipole. Now if the electron is moving, because electron is also charged, that means electron is moving. Let us suppose the electron is moving in this direction. Electron is moving in this direction. Now orbital magnetic moment. Orbital magnetic moment, let us suppose mu L is the orbital magnetic moment. Magnetic moment is what? Current multiplied by area. Let us suppose this is the current and this is the area, okay, and this is the radius small r. You know that current will be in opposite direction of motion of the electron. Current will be opposite direction because the direction of current is the motion of positive charge and opposite to the motion of the negative charge. If the electron is revolving in this direction, current is in this direction, okay. If the current is in this direction, magnetic moment will be downward. Magnetic moment, because area vector will be downward, and direction of area vector is direction of magnetic moment, okay. Orbital magnetic moment. Now here I, in place of I we can write Q upon T, okay. Now here Q is what? E. T is, let us suppose, time period, and in place of time period you can write what? You can write velocity is equals to 2 pi r upon v. Time period is equals to 2 pi r upon v. Here you can put what? 2 pi r upon v means EV upon 2 pi r. You can put here in place of I, EV upon 2 pi r, where v is the velocity, and in place of area you can write pi r square. Pi cancel, 1 r cancel, EVR upon 2 is the magnetic moment. Magnetic moment is downward. Now here the third point, that is gyromagnetic ratio. If L is the angular momentum is what? mvr. You all know, where m is the mass of electron, mvr, and ratio of orbital magnetic moment and angular momentum, this ratio is called gyromagnetic ratio, okay. EVR upon 2 multiplied by 1 upon MEVR. VR cancel out, E upon 2 ME. This is the ratio of orbital magnetic moment and orbital momentum or angular momentum. L is the angular momentum, okay. Now gyromagnetic ratio is mu L upon L, that is E upon 2 ME. The value of this is approximately 8.8 into 10 to the power 10. This is charge and this is mass, means unit of this is what? Coulomb per kilogram. Now this point, the Bose quantization condition. I hope you have studied in class 11th chemistry, structure of atom, condition of Bose. means Bohr's quantization condition. According to this, angular momentum of any orbit is equals to nh upon 2 pi, where n is the principal quantum number, means number of orbit. If you place in place of n, if you put here 1, then means first orbit in place of n equals to 2, means n is equals to 1, 2, 3 dash dash dash, means for 1 first orbit, for 2 second orbit. Okay, this is the this is the Bohr's quantization condition. You can put here mu L upon L. Mu L upon L is equals to E upon 2 me. E upon 2 me. E upon 2 me. Here mu L is equals to E upon 2 me into L, and E upon 2 me is equals to, in place of this you can write h upon 2 pi. Hope you are getting. Okay, this is the formula. Now next, that is Bohr's magneton. Bohr's magneton is the orbital magnetic moment of electron. Orbital magnetic moment of electron in first orbit. If the orbit is first, then this is called Bohr's magneton, means in place of n you will write what? 1, means E upon 2 me h upon 2 pi is called Bohr's magneton. Bohr's magneton, or simply a Bohr's magneton. Okay, now here this is the formula for orbital magnetic moment. Orbital magnetic moment is a vector quantity. This is downward, and angular momentum according to right hand screw rule. Electron is moving in this direction. That means the direction of angular momentum will be upward. This is the direction of angular momentum. Now this formula in vector form can be written as E upon 2 me into vector L, but there should be a minus sign. Why minus sign? Because the angular momentum and magnetic moment is in opposite direction. This is the vector form of magnetic moment, orbital magnetic moment, and angular momentum. Okay, hope you are understanding, and thanks for watching this video.